Hello students, welcome to this lecture, one coordinate geometry. Okay, so let's get started. So in today's lecture, we will cover introduction, distance formula, sections formula, and examples. Okay, so you have studied that locate the position of a point on a plane. Okay, basically we have studied that to locate the position of a point on the Cartesian plane, we require a pair of coordinates axes. Okay, so we need pair of coordinate axes as x-axis and y-axis, and the distance of a point from the y-axis is called the x-coordinate or abscissor. Okay, and the distance of a point from the x-axis is called y-coordinate or ordinate. So the coordinates of a point on the x-axis are of the form x, 0. Okay, and of a point on the y-axis is of the form 0, y. So a point on the y-axis are of the form 0, y. So you know about Cartesian plane that actually consists of a pair of coordinate axes. Okay, so this is x-axis, this is y-axis. So here the point on the x-axis are of the form x, 0, and the point on the y-axis are of the form 0, y. Okay, so in this chapter we will learn how to find the distance between 2 points whose coordinates are given to us, and to find the area of the triangle formed by 3 given points. Okay, so our motive of this lecture is basically here we learn how to find the distance between the 2 points whose coordinates will given to you, and to find the area of the triangle formed by 3 given points. Okay, so you will also study how to find the coordinates of the point whose divides a line segment joining 2 given points in a given ratio. Okay, so in this chapter basically we learn distance formula, then we learn about how to find area of the triangle formed by 3 given points. Okay, and then we learn how to find the coordinates of the point which divides a line segment joining 2 given points in a given ratio. Okay, so let us consider the following situation. So here we consider this situation. So a town B is located 36 km east and 15 km north of the town A. And how would you find the distance from town A to town B without actually measuring it? Okay, so we have given this situation. We have this. We have a town B which is located 36 km east and 15 km north of the town A. Okay, so we have here two towns. One is A and another is B. And B town is located 36 km east and 15 km north of the town A. And how would you find the distance from town A to town A to town B without actually measuring it? Basically, we have to find this distance, A to B distance. Okay, without actually measuring it. Okay, so let us see. This situation can be represented graphically, that is shown in this figure. Okay, so you may use here Pythagoras theorem to calculate this distance. Basically, here this is a right angle triangle, and this distance AB is basically hypotenuse of this triangle, right angle triangle, and here this distance is actually base of this right angle triangle. Okay, and this is height of this right angle triangle, and here we can use Pythagoras theorem to find the distance from town A to down B. Okay, so we know the Pythagoras theorem that says to us hypotenuse square, this is equal to base square plus height square. Okay, so we can use this theorem and we can easily find this distance. Now suppose 2 points lie on the x-axis, then can we find the distance between them? So we know any points which lie on the x-axis are of the form x comma 0. Okay, so now if we have 2 points on the x-axis, then we can easily find the distance. Okay, so for instance, consider 2 points on the x-axis, a 4 comma 0 and b 6 comma 0. Okay, so that is shown in figure this. Okay, here the points a and b lie on the x-axis, and from the figure you can see that this distance OA, this is equal to 4 units. Okay, and here OB, this distance is equal to 6 units. So now we have to find distance between A to B. Okay, so how can we find it? So we can, therefore the distance of B from A, that is AB. Okay, and this is actually equal to OB distance minus OA distance, that is equal to 6 minus 4, and this is equal to 2 units. Okay, so if 2 points lie on the x-axis, then we can easily find the distance between them. Okay, so it is easy to find distance between 2 points that lies on the x-axis. Okay, so now suppose we take 2 points lying on the y-axis. So you know any point on the y-axis are of the form 0 comma y. So here we can take point 0 comma 3, 0 comma 8. Okay, and here can we find distance between them? So if the point C 0 comma 3 and D 0 comma 8. So here you can see this figure. So here if you see this figure here, distance between O to C, this is actually equal to 3 units. Okay, and this distance O to D is equal to 8 units. Okay, so distance between C to D, this is actually equal to OD, distance between O and D, minus distance between O and C, and that is equal to 8 minus 3, and this is equal to 5 units. Okay, so distance between these 2 points is equal to 5 units. Now next, you can you find the distance of A from C, that is shown in figure A from C. Can you find the distance A from C? So the coordinates of A are 4 comma 0 and the coordinates of C are 0 comma 3. And now our question is, can we find the distance of A and C? Okay, so here since we know OA, this is equal to 4 units, and OC, this is equal to 3 units, and the distance of A from C, this is actually equal to S is equal to square root of 3 square plus 4 square, that is equal to 5 units. Okay, so here you can find the distance of C from A by using Pythagoras theorem. Okay, so here you can if we take this triangle OAC, here this triangle is a right angle triangle since this angle is 90 degree. Okay, so and here the base is OA, and here base OA is equal to 4 units, and the height OC, this is equal to 3 units. Okay, and now if we use Pythagoras theorem, then we can easily find the distance of A and C, that is actually equal to square root of OA square plus OC square, that is equal to square root of 4 square plus 3 square, and this is equal to square root of 16 plus square root of 9, that is equal to square root of 25, that is equal to 5 units. Okay, similarly you can find the distance of B from D. Okay, so similarly you can find the distance from B to D. Here the coordinates of B are 6, 0 and the coordinates of D are 0, 8. Okay, so but if now in this case, here we can take this right angle triangle ODB. Okay, and then we can use Pythagoras theorem, and by using Pythagoras theorem, here we can find the distance B and D. Okay, and here the distance BD, this is equal to actually 10 units. Now if we consider two points not lying on the coordinate axis, then can you find the distance between them? So if we have 2 points that not lying on the coordinate axis, that means they are not lying on x axis or y axis, and then our question is, can we find the distance between them? So our answer is yes, we can find distance between them. So we shall use Pythagoras theorem to do so. Okay, so here we explore some example. So let us see an example. So here you can see this figure. So in this figure, the point P, that is actually 4, 6, and the point Q, that is 6, 8, that lie in the first quadrant. Okay, yeah, these 2 points lie on the first quadrant. And here how do we use Pythagoras theorem to find the distance between them? Okay, so here we can draw PR and PS. Okay, so we can draw PR and PR and QS. Okay, perpendicular to the x-axis from point P and Q. Okay, so here we draw a line perpendicular one x-axis from P and Q point, and also draw a perpendicular from P1QS. So here we draw this perpendicular from point P1, the line QS. Okay, and to meet QS at T point, here this perpendicular meet at the point T. Okay, so then the coordinates of R and S are 4, 0 and 6, 0 respectively. So here the coordinates of R are 4, 0 and the coordinates of S are 6, 0. Okay, and now RS, this is equal to 2 units. Also QS, this is equal to 8 units. Okay, so TS, this is equal to PR is equal to 6 units. Therefore QT, this distance, this is actually, this distance 8 minus 6, that is equal to 2 units. Okay, so this is actually 2 units. Okay, so here QT, this is equal to 2 units. QT, this is 2 units, and PT, this is equal to RS, and RS is equal to 2 units. Okay, so now we can use the Pythagoras theorem, and we can find P. We have PQ square, this is equal to PT square plus QT square. Okay, so here basically we use this triangle. So here in this triangle, PT square plus QT square, this is equal to PQ square. Okay, so here we have the value of PT, this is equal to 2, and the value of QT is equal to 2. So PQ square, this is equal to 2 square plus 2 square, that is equal to 8. Okay, so PQ square, this is equal to 8. And so PQ is equal to 2 times root 2 units. Okay, so how will we find the distance between 2 points in 2 different coordinates? So here in this example, we take these 2 points, one first coordinate. Okay, so now if we have 2 points, 2 different coordinates, then how can we find distance between them? Okay, so consider for that case the points P, that is 6, 4, and this point lies on the first coordinate. Okay, and we take this point Q, minus 5 comma minus 3, and this point lies on the third coordinate. Okay, third coordinate. And here we draw QS. We draw QS. This is perpendicular to x axis. Okay, and also draw the perpendicular PT from the point P on the QS extended line. Okay, and to meet y-axis at the point R. So here this line segment meet at the point R, one y-axis, and now here the PT this is equal to 11 units. Why this is? PT is basically this is okay. So this is our PT, and here the coordinates of T is basically minus 5 comma 4. Okay, so this coordinate, this is actually minus 4 comma 4, minus 5 comma 4. Okay, and this is 6 comma 4. So here this distance here, from this here we have 5 units, and from here we have 6 units. So here the length of PD, that is equal to 11 units. Okay, and QT this is equal to TS plus QS. Okay, and here the length of QS is minus 5 units. Okay, and the length of ST is equal to 4 units. Okay, so the length of QT is equal to 4 plus 3, that is equal to 7 units. Okay, so QS is 3 units length and ST is equal to 4 units. So QT this is equal to 7 units. And now using the Pythagoras theorem to the right angle triangle PTQ, then we get PQ, that is equal to square root of 11 square plus 7 square. Okay, and this is equal to root over 170 units. So basically we use this right angle triangle. Okay, and here the base is PT and the height is QT, and we know the length of PT is equal to 11 units and the length of QT is equal to 7 units. Okay, and then by using Pythagoras theorem we get the length of PQ, that is equal to root over QT square plus PT square, that is equal to root over 11 square plus 7 square, that is equal to root over 170. Okay, root over 170 units. So let us now find the distance between any two point P x1 comma y1 and Q x2 comma y2. Okay, so if we have any two arbitrary points P x1 comma y1 and Q x2 comma y2. Okay, so here we first have to draw PR and QS perpendicular to x-axis. Okay, so here we first draw PR and QS perpendicular to the x-axis. Okay, and a perpendicular from the P, one QS is drawn meet at the point T. Okay, at the point T. So this is our perpendicular, one QS from the point P and it meets at the point T. And now then here OR this is equal to x on units, and here RS is equal to y2 x2 minus x1 units. Okay, and so here PT is equal to x2 minus x1 units, and here this is actually PR is y1 units and QS is y2 units. So QT is equal to y2 minus y1 units. Okay, so now from this right angle triangle PQT, here we can use Pythagoras theorem Pythagoras theorem. So now applying the Pythagoras theorem in triangle PTQ, we get PQ square. This is equal to PT square plus QT square. And here we find the length of PT is equal to x2 minus x1 and the length of QT is equal to y2 minus y1. Okay, so PQ square, this is equal to x2 minus x1 whole square plus y2 minus y1 whole square. And now therefore the distance between P and Q, that is PQ, is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so here note it down that since distance is always non-negative, here we take only the positive square root. Okay, so the distance between 2 points, distance between the points P of x1 comma y1 and Q of x2 comma y2 is PQ is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square, which is called the distance formula. Okay, so if we have any 2 points P x1 comma y1 and Q x2 comma y2, then distance between these 2 points, this is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so here remarks. So in number 1, in particular, the distance of the point P of xy from the origin is given by OP, that is equal to square root of x minus 0 square plus y minus 0 square, that is equal to square root of x square plus y square. Okay, and the second remark, we can also write PQ. This is equal to square root of x1 minus x whole square plus y1 minus y2 whole square. Why we can write this? Since here if we take x1 minus x2 whole square or x2 minus x1 whole square, that is actually same thing. Okay, so that's why we can also write PQ is equal to square root of x1 minus x2 whole square plus y1 minus y2 whole square. Okay, so here we discuss now an example that will clear your concept. Okay, so in this example, it said to us, do the points 3, 2, minus 2, minus 3 and 2, 3 form a triangle. Okay, so it asks this question asks to us, if we have these 3 points, then will they form a triangle? So if so, name the type of triangle form. Okay, so which type of triangle will form, that we have to name, that we'll have to give some name. Okay, so here let us apply here the distance formula to find the distances PQ, QR and PR. So where P is 3, 2, Q is minus 2, minus 3 and R is 2, 3. Okay, at the given points. So we have the distance PQ. This is equal to actually square root of 3 plus 2 whole square plus 2 plus 3 whole square. That is equal to square root of 5 square plus 5 square, that is equal to square root of 50, that is equal to 7.07 approx value. Okay, and the distance QR, this is equal to square root of minus 2 whole square plus minus 3 whole square. Okay, and this is equal to square root of minus 4 whole square plus minus 6 square, that is equal to square root of 52, and this is approximately equal to 7.21. Okay, and now distance PR, this is equal to square root of 3 minus 2 whole square plus 2 minus 3 whole square. Okay, and this is equal to square root of 1 square plus minus 1 whole square, that is equal to square root of 2, and this is approximately equal to 1.41. And now by the converse of Pythagoras, by the Pythagoras theorem, PQ square plus PR square, this is equal to QR square theorem. Okay, so we have angle P is 90 degree, therefore PQ is a right angle triangle. So actually this is converse of the Pythagoras theorem. So we have this PQ square plus PR square, this is equal to QR square. Okay, then here the angle P is 90 degree, and therefore PQR is a right angle triangle. Okay. So here these 3 points forms these 3 points form a triangle, which is actually right angle triangle. Okay, so here we first find the distance between 2 points. Okay, see, if we let this is P, this is Q, this is R, then we find the distance PQ, distance QR, and the distance PS. Okay, and PR. Okay, so then we use this condition PQ square plus PR square, this is equal to QR square, and by the converse of the Pythagoras theorem, here it implies to us angle P is equal to 90 degree. Okay, and therefore PQR is a right angle triangle. So since the sum of any two of this distance is greater than the third distance, okay, so therefore the points PQR form a triangle. So when 3 points will form a triangle when sum of any to this distance is greater than the third distance. Okay, so if we take from first, if we find the distance PQ, QR, and PR, and if we sum them, any two of them, if we take sum, okay, that if we get this is greater than the third distance, then these 3 points PQR form a triangle. Okay, and in next example, here we have to show that the points 1,7, 4,2, and -1, -1, and -4, 4 are the vertices of a square. Okay, so here we have given some coordinates of the point. Okay, and here we have to show that these 4 points are the vertices of a square. Okay, so let us show this. So here we let A 1,7, B 4,2, and C -1, -1, and D -4, 4. Okay, be the given points. And one way of showing that ABCD is a square is to use the property that all its sides should be equal. Okay, so we can use this property. All sides of a square should be equal. Okay, and both its diagonals should also be equal. Okay, so now here the distance AB, that is equal to square root of 1 minus 4 whole square plus 7 minus 2 whole square, that is equal to square root of 9 plus 25, that is equal to square root of 34. And the side BC, the distance BC, this is equal to square root of 4 plus 1 whole square plus 2 plus 1 whole square. This is equal to square root of 25 plus 9, this is equal to square root of 34. Okay, and here CD, this is equal to square root of -1 plus 4 square plus -1 minus 4 whole square, and this is equal to square root of 9 plus 25, that is equal to square root of 34. Okay, and here DA, this is equal to square root of 1 plus 4 square plus 7 minus 4 square, this is equal to square root of 25 plus 9, this is equal to square root of 34. And AC, this is equal to also, this is actually equal to square root of 1 plus 1 square plus 7 plus 1 whole square, this is equal to square root of 4 plus 64, this is over 68. So one diagonal is square root of 68 units, and other diagonal BD is equal to square root of 4 plus 4 square plus 2 minus 4 square, this is equal to square root of 64 plus 4, and this is equal to square root of 68. Okay, so here AB, BC, CD, and DA are equal. Okay, so all sides are equal, and here the diagonal AC and BD also equal. So while the 4 sides of the quadrilateral ABCD are equal, and its diagonal AC and BD are also equal. Okay, so therefore ABCD is a square. So ABCD is a square. I stop here this lecture. Thank you very much to all of you.